All right, I think I got one more trig verification in me. This again was one of the three that was given to you on final exam review number one. I think this might have been the second problem, but the task is to show that, okay, can we show that this expression right here is equal to this trig expression over here? And so again, a little equal sign and a question mark over that, because we'd like to verify that are these two things the same. And so right now, we don't know. So again, just a few reminders about some of the tips and tricks. We're going to turn everything into sines and cosines. We're going to take advantage of some of our algebraic ideas, factoring and canceling, conjugates might be useful here. The idea of getting common denominators if we want to add or subtract fractions. Invert and multiply if we're perhaps dividing fractions by fractions. And at some point, this always seems to come into play, the Pythagorean identity. So the way it kind of flows is you start by turning everything into sines and cosines. You then start doing some algebraic, hocus pocus on both sides, trying to get them the same. And at some point, the last big algebra trick might be the Pythagorean identity and doing some kind of a substitution right there. So let me kind of pull all these things aside. And again, let's remind ourselves what we are not going to do. We are not going to assume any properties of equality. In other words, I'm not going to add something on both sides. I'm not going to subtract something from both sides. I'm not going to multiply through by something, because those are properties of equality. And we cannot assume equality. We're trying to verify or prove, if you will, that equality exists. So let's get on with this. So again, the first step is turn everything into sines and cosines. And right now, all this stuff is pretty much done. Can't really do anything with that. But on the other side here, we could turn cosecant into, this would be 2 times, now cosecant is the reciprocal of sine. So 1 over sine squared. 1 over sine is the reciprocal of cosecant, so when you square it, 1 squared is 1, and sine squared is sine squared. So, or more simply, this would be 2 over sine squared. So that's the right-hand side. So you're looking over here. This side right now looks nothing like this, but maybe we can do some algebra over here, and maybe we can end up getting it to look like this side over here. So now we'll bounce back to the left-hand side, and we realize, okay, we're trying to add two fractions here. So I want to get these, I need to add two fractions. Well, in order to add two fractions, I need a common denominator. And so you think back to what you may have done when you had things like, maybe you had 1/5 plus 1/7, and you might recall that, well, one trick was multiply this by 7 over 7, multiply this by 5 over 5, because then it gives you common denominators for both fractions, and you can then add them together. So we're going to try and do the same thing here. Is we're simply going to multiply each of these by the other. In other words, we're going to multiply this by 1 plus cos x, 1 plus cos x. Notice this is all kind of also connected to kind of the sort of the conjugate idea. And then this one right here, let's multiply this one by 1 minus cos x and 1 minus cos x. Multiply at the top and bottom by the same thing. You're not changing the value of the relationship. You're merely changing its appearance. So let's see what that does for us. In the first case, we have the top 1 times 1 plus cosine x. That would be 1 plus cosine x. That's not too bad. And then the bottom. And here we got to be a little careful with the bottom, because now we're going to have to distribute. And so we're going to have, we'll see, 1 times 1 is 1. And then I've got 1 times negative cosine, that's minus cos x. And then multiplying here, that would be plus cos x. So these, again, not really a surprise, is these are going to cancel out. We're kind of setting up a difference of squares situation. And then we're going to have negative times positive negative, and then this will be cosine squared. So this first fraction, just to kind of write it a little more cleanly, 1 plus cos x on top, and then we have 1 minus cos squared on the bottom. 1 minus cos squared of x. Now we'll go over to the other fraction and we'll see what happens here. 1 times 1 minus cosine is 1 minus cosine x. And then on the bottom, we will distribute once again. Now this is going to work out to be the same denominator. Let's go through the steps. 1 times 1 is 1. We have plus cosine. And then here we've got minus cosine. So those cancel out. Excuse me. And then we've got negative times positive, so negative cos squared. Didn't leave myself a lot of room here, but hopefully you'll be okay. So then this is going to be 1 minus cos x over, and then 1 minus cosine squared. Again, we got the denominators to be the same, and that was the whole point of choosing these multipliers here, was intended to get these denominators the same. Now, let's see, between them, it was a plus sign right here, so plus sign. So now I've got common denominators, so I can add these things together. And so I've got 1 plus cos plus 1 minus cos. So this is pretty much just, let's put all this stuff together right here. There's really no distributing. It's just a matter of like terms. So I've got a 1 plus a 1, so that would be a 2. And then I've got plus cosine plus a negative cosine. Well, those are going to cancel one another out. So all I have is 2, and that's great because that's what I'm looking at over here is 2. So I'm feeling pretty good. And then I put this over the common denominator, which is 1 minus cos squared. So here we are in the case of, okay, these are almost the same. We have 2 up top. Well, again, if you think about the Pythagorean identity, sine squared plus cos squared, sine squared plus cos squared makes 1. Well, that means that 1 minus cos squared makes sine squared. And for that matter, 1 minus sine squared makes cos squared. So 1 minus cos squared, that would just can be replaced with sine squared. And now we have it. So this side will just kind of carry down. 2 sine squared x. And now we can say, yes, we have verified the identity. We've shown that these two things really are equal. So the idea is turn everything into sines and cosines and then start to kind of do some algebra. Here's a case of where we're going for common denominators. And this is a really nice thing here with this sort of using the difference of squares idea. It ends up getting used quite a bit in these trig verification problems. Once we have our common denominators, we can then put all the terms of the numerators together and simplify. And then finally, we kind of take advantage of the Pythagorean identity to make a substitution, and we get these two sides looking identical. So thanks for watching.